Hello, my name is Zach Pratt, and I'm an instructional coach at Parker High School in Janesville, Wisconsin. In my role, I work with our science department to improve instructional practices and curriculum for our students. The images on the slide represent examples of diverse representation in biology. While there are many groups underrepresented in this field, I do know that I'm not addressing them all. My goal in this talk is to address one part of a problem that I see, which is the opportunity gap experienced at Parker High School from 9th to 10th grade, and that continues to widen afterward. Parker High School has roughly 1,300 students. 3 out of every 5 students are economically disadvantaged. 70% of our students are white. 14% are of Hispanic or Latino heritage. 7% of our students are of 2 or more races, and 6% of our students are Black or African American. The demographic information from our middle schools suggests that our minority population will increase, as will the percentage of students that are economically disadvantaged. Like many schools, we currently have an issue with chronic absenteeism. While the percentage of Hispanic and Latino students and white students that are truant have decreased over the past 2 years, chronic absenteeism of Black students and students who are of 2 or more races remains high and unchanged. One of the problems that could be contributing to this symptom is the cultural and societal relevance of our science curriculum to the lives of our students and the representation of people of color in our curriculum. By the time that our students reach high school, they have been tracked into honors and non-honors versions of science courses, particularly biology and biology honors. You can see in this data an unequal distribution of students in honors and non-honors biology. By 10th grade, tracking expands into physical science, chemistry, and chemistry honors, and these are in order of increasing rigor. The data from this year shows that our students of color are enrolled in physical science at rates that are higher than their enrollment at the high school. We have a lower percentage of Black and Hispanic and Latino students and students of 2 or more races in chemistry honors than we have in either physical science or chemistry. This tracking likely contributes, but is not the only cause of differences in our ACT scores among various racial and cultural groups. The gap between white students and students of color on standardized testing increases throughout high school. Now, if I had time, I would discuss how trends such as these are likely upholding the lack of diversity within the science fields. For now, I'll just say that we need diversity in science to solve complex problems, yet we continue to lack it. There are a variety of action plans that I could have taken. For example, I could have proposed to end honors and non-honors versions of courses. At least one school in our area has stopped tracking. However, this change is a district decision and is likely not something that our district is ready for. Instead, I've decided to approach our problem through culturally relevant teaching. Our curriculum does a good job of creating opportunities for culturally responsive teaching, such as group discussion and a variety of ways to show learning. Yet there are a few examples of scientists of color or from other marginalized groups, such as people with disabilities, in our resources. My plan is to make a repository of resources that science teachers could use in biology to increase representation of people of color, to show that science knowledge can be based on racist views, and to show that knowledge is not neutral, and to make science culturally relevant to the students of Janesville. And for an extended look at this resource, you can click on this particular tab right here, or this link, to take a look at it. To measure effectiveness, I would check enrollment in our 10th grade courses, looking specifically at demographics across the 3 classes that make up our 10th grade offerings. I would also look at the enrollment specifically in physical science, expecting a decrease if this plan has an effect. Finally, I would analyze our pre-ACT scores, looking for a decrease in the gap between white students and our students of color. This plan supports the district goal to close the achievement gap between white students and students of color. So I'm going to provide two specific examples of this plan. Our first unit in biology is ecology. In the past 5 years, Janesville has removed an aging hydroelectric dam along the Rock River. Now, Native American tribes in the western U.S. have been advocating for the removal of similar dams along rivers such as the Elwha River, which prevents salmon from reaching their breeding grounds. This, along with overfishing, has reduced the salmon populations. And this example could be applied to discuss the effect of habitat fragmentation on biodiversity, food webs, and population size, all of which our students currently explore. Other examples where we could include perspectives not only in biology but in other science courses include the ecological impact of a GM plant on Janesville, and this plant closed in 2008. We could look at the life of Luis Walter Alvarez, whose work in physics led to microwave radar, and we could also look at gender-inclusive biology. While this last one is a catch-all phrase, it refers not only to disrupting the narrative that biological sex is binary, but it also addresses the way in which we genderize non-gendered structures such as daughter cells and sister chromatids. Another aspect of this plan is to address sexism, ableism, and racism in science. In our unit on evolution, our students explore antibiotic resistance, a crisis which they will be asked to help us solve in the future. Science provides the opportunity to discuss medical racism, particularly the Tuskegee syphilis study. In the study, low-income Black men in Alabama were deceived in order to study the long-term effects of syphilis. Even after a treatment for syphilis was available in the 1940s, this study continued. It is argued that this study is one of the events that contributed to the distrust that Blacks and African Americans have for medical professionals. Other relevant examples of systemic racism in science include the lead pipes that led to the Flint water crisis, Aunt Henrietta Lacks, whose cells have been immortalized without her consent and continue to be used in scientific studies, and designing research areas for people with disabilities. While I do not think that this plan alone will fix the opportunity gap that exists in high school science, I do believe it can be one piece to start closing the gap. Thank you for your time and attention.